Hello everyone, buongiorno. Today I want to tell you about DataStore. I want to share my preference for DataStore. So DataStore is a replacement for SharedPreferences, and it has two different implementations, Preferences and Proto DataStore. Preferences DataStore allows you to save small primitive data in key value pairs, while Proto allows you to save small type data backed by protocol buffers. But under the hood, both of these implementations are backed by coroutines and flow. So I said that DataStore was created to replace SharedPreferences. But what's wrong with SharedPreferences? Why do they need replacement? So first of all, SharedPreferences allow us to save small primitive data in key value pairs. But while it comes with a lot of advantages, it also comes with a lot of disadvantages. So for example, SharedPreferences allows us to have a synchronous API. So to do that, you would get the SharedPreferences from the context, you would call edit on them, and then you would put the value based on the key and value pair. And I think this is where the first problem appears, because it's not strongly typed. So it's so easy to just call put int instead of put boolean, for example, for a preference key. There's nothing to tell us that this is that gives us type safety. Next, SharedPreferences actually allows us to call two methods, apply or commit. And if you're anything like me, you can never remember which one is which and when you should use what, and you end up having to look in the documentation. So what happens with apply and commit? So apply changes data immediately in memory and on disk asynchronously, while commit changes data on disk synchronously. So here, it actually brings another problem, that this is a transactional API that doesn't have consistency guarantees. Just because something is saved, and when you're using apply, something is saved in memory, but then it's not really saved on disk, so you're missing this consistency guarantee. But then you're saying like, okay, then I could just call editor apply, and then all the work is done asynchronously, and everything looks like safe to call on the UI thread. Similar for commit, it says that the data is changed on this synchronously, and it almost looks like it's easy to be called on the UI thread. Well, it's easy, that doesn't mean that it's safe. So commit will take a bit of a time to actually write the file, because SharedPreferences is in the end backed by a file. So it's a lot of input-output operation that needs to be done. And then SharedPreferences does have an asynchronous API with apply, but this one also comes with some disadvantages. So the problem appears when these changes are actually made on disk. So actually, once you're calling apply, SharedPreferences schedule some fsync calls. And then in these fsync calls, this is when the actual file will be written. And fsync will actually block the thread. And this is called whenever a service or an activity starts or stops. So this means that if you're working with SharedPreferences, whenever you're starting or stopping an activity or a service, you'll end up having a little bit of delay just because you're saving data. Next, when it comes to asynchronous API, SharedPreferences does provide a way to listen to when SharedPreferences are changed. So it has a register on SharedPreferences change listener. But even here, we have another gotcha, that this callback is run on the main thread. But SharedPreferences has no way of signaling errors. Actually, you'll just get a runtime exception being thrown. And even if you have a parsing error where the SharedPreferences file can't be read, even that is also a runtime exception. You can't really differentiate between these, so you can actually get to handle them properly. And also, SharedPreferences doesn't handle migration. So let's say that you decide to change the type of one of your values from int from boolean to int, for example. Well, you'll have to make all of the changes needed to migrate to this new version manually. And SharedPreferences is part of the Android OS. It doesn't come bundled. So this means that it's hard to actually make changes and improve it. So with all of these advantages and disadvantages, what do we do now? Well, we can use Preference or Proto DataStore. So the aim of DataStore is to address a lot of the problems that SharedPreferences bring. While DataStore doesn't have, at least for now, a synchronous API, it addresses a lot of the other problems, including the type safety if you're using a Proto DataStore. So you might be asking, okay, why not use Room? In the end, Room brings a lot of these advantages that we see here for preferences, preferences and Proto DataStore. Well, the question appears around when should you use Room and when should you use DataStore. So if you have to save large data sets, if you need referential integrity, if you need to query data, and especially if you have to do complex queries, or if you need to do partial updates, DataStore is not the library to use. This is where you should use Room. But if you need to save small data, that's simple, that doesn't need to be queried in any complicated way, this is where DataStore could be a handy replacement to SharedPreferences. So let's take an example and see how our code would look like. So let's say that we have a to-do list application. And in this to-do list, we have a toggle that allows us to toggle whether we should show or not completed task. And of course, this is a flag that we would want to persist. So let's start by saying how we can implement this using Preference DataStore. So Preferences DataStore allows us to save small primitive data in key value pairs. So to create a data store, we just call create data store with the name of our preferences. So under the hood, actually DataStore will also use a file to save the information that we provide. And even more, actually, this file is backed by proto buffers. But this is not something that you are actually ever interacting with if you're using Preferences DataStore. If you want to read the data, you would call datastore.data, and this will return a flow of preferences. I must mention here that this preferences object that you see here is a class that is defined in DataStore and has nothing to do with the SharedPreferences that you might know. So, if we want to get a specific value, so for example, our show completed key, then we would use something like this. We would get from the datastore.data, we would map it, and then return the preferences of show completed key. And then we can define what should happen if the value isn't set. So for example, here, we might return false. But I said that the preferences actually allows us to only save primitive data. So right now, the supported types are int, long, boolean, float, and string. What I didn't show for now is what is that show completed key? Well, actually, this is something that's created by that's created using the preferences key. So what I like about this approach is that it automatically connects a key with the specific type. So it gives you, again, this a little bit of type safety between what you're expecting. You no longer have that put int or put boolean that it's easy to miss or when you're using SharedPreferences. So if something goes wrong while trying to read the data, then this can be handled like any other error that you would handle using flow. So you would use the catch operator and then handle the exception that's being thrown. So DataStore will throw an IO exception if an error was encountered when reading the preferences, or just the exception that was encountered if anything else happened. If we want to write data, then we would use datastore.edit. And this datastore.edit is a suspend function. So here in the Lambda, we would get a reference to a mutable preference. So now we can actually modify the information inside our preferences. So here we just call preferences with a key, and then we set the new value. What's interesting about this datastore edit is that this is an atomic read, modify, write operation. Once we enter the edit method, the latest value is read and set in the preferences. And then we can modify our specific preference. And then any other preferences that we have set won't be modified, won't be affected. And then afterwards, the preferences will be written on disk. And only once that happens, once the data is written on disk, only then the coroutine completes. So this ensures that you have this atomic operation, that it guarantees consistency. Of course, DataStore edit can also throw an I/O exception if something happened while trying to write the data on file. By default, DataStore.edit is called on dispatchers.io. So like this, it means that this call is safe to be called from the main thread because under the hood, DataStore will just ensure that the right dispatcher is used. So if you prefer using something else than dispatchers.io, maybe your own scope, you can pass it in the create DataStore method. And I actually like this because DataStore is quite flexible. It provides good defaults, but it also gives you the flexibility to set the values that you need. So what if you need to migrate? You want to migrate from SharedPreferences to Preferences DataStore. Well, to do this, in the create DataStore, you add a value for the migrations parameter. So more precisely, you define you create a new instance of a shared preferences migration, passing in the context and the name of the shared preferences file. And that's it. Because shared preferences and DataStore preferences are key value based, then DataStore will automatically know how to convert between these two. What's important, though, to mention is that whenever you're using DataStore, you'll have to make sure that you're using the same key like you were using with shared preferences, so the same name for the key. But what if you need to migrate from one version of Preferences DataStore to another? So let's say that you're changing the value that you have in your DataStore. So for example, let's say that we define our update show completed, which is a Boolean initially. We want to change it to an int. Maybe we want to have 3 states for it, something like show completed not set, true, and false. Well, if you want to make this change from Boolean to int, then our show completed preferences key from Boolean should change to int as well. And then we will have to implement our own migration. So to do this, we implement a data migration class. So here we can define as a member reference to the old key, so the preferences key of Boolean with the same name that we had before. Then the first method that we need to implement is should migrate. So this tells DataStore whether we should migrate or not. So we can say that, and we get as a parameter the current data in the preferences. So we know that we can check whether the current data contains the old key. And if it contains it, then we would want to migrate it. When migrating data, we can check, we can use the current data. And then based on the current data, we will create our new show completed based on whatever logic we have there to convert between Boolean and int to int. And then we'll just return the new data. And then finally, data migration class also allows us to clean up. So this is something that should be called whenever you have something outside DataStore that needs to be cleaned up. So maybe, I don't know, maybe you're working with some file or with other kind of data that needs cleaning up. So make sure that you're not calling any DataStore specific functionality here, as you'll end up in a deadlock. And then once we define our migration, we just need to pass that migration to the list of migrations. So whenever you're working with, if you want to work with Preferences DataStore, well, you need to add the dependencies. And recently, actually, in one of the latest alphas, DataStore changed the way the dependencies are provided. So now you can decide whether you want to use DataStore preferences without any Android dependencies, or whether you need some Android dependencies. So more precisely, DataStore preferences will contain the migrations, the shared preferences migration. But if you don't need shared preferences migration, because this is the first time you want to save these kind of preferences in your application, you can just import the DataStore preferences core. And this also means that this is a library that can be used in a module that's pure, that doesn't use any other Android dependencies. That's like a pure Kotlin module. Then Proto DataStore allows us to save small type data backed by protocol buffers. A lot of things for Proto DataStore are similar to Preferences DataStore, so I'll focus on the differences between the two. So protocol buffers are actually a mechanism for serializing structured data. They're small, they're fast, and they're simple. And if you've never worked with them, let me give you a very quick TLDR of how to use protocol buffers. So when you use protocol buffers, you have to define a proto file. Inside, you would define a message with a name. And inside the message, you would define your types. And then at compile time, this will generate a class. So you will end up with a user preferences class that contains a Boolean field that's called show completed. And then that one that you see there is just an index that's used internally by protocol buffers. But what protocol buffers allow us is to create more complex data. So let's say that in our app, we also want to be able to sort our tasks. So we want to be able to sort them either by deadline, by priority, or by deadline or priority. This is the perfect case of using enums. So we can define our enum that's called sort order that has several values. And then our user preferences object can keep a reference to a sort order. Then we need to tell DataStore how to interpret, how to read these products. And to do that, we would use a user preference serializer. So the serializer will contain the type of user preference. And then two methods, read from and write to. And you see that except the type of the preference that you have, things are pretty general. So chances are you'll end up using this or copy-pasting this kind of class everywhere in your app, just changing the type of serializer. But also, the serializer allows us to define a default value. So this is the value that should be used when no default values have been set. So this allows us to set default values for our user preferences. To create Preferences DataStore, we call create DataStore, passing in the file name and a serializer. But what we get now in return is a data store of user preferences, so the actual preferences that we want to save in DataStore. Then to read data, we call datastore.data. And then in return, we get a flow of our user preferences. What I forgot to mention with Preferences DataStore, that also applies for Proto DataStore, every time you change the data in the preferences, then this flow will emit. So for example, whenever we change the show completed flag, this user preferences flow will emit with the new value of the user preferences. If we are only interested in a specific value, then we can just map the flow like we would with any other flow. Similar, when we talk about writing data, Preferences Proto DataStore allows us to use a datastore.update data method. And this one is also a suspend function. And as a parameter, we get the user preferences. But unlike the Preferences DataStore, this is no longer a mutable preference. This is the actual user preference that's saved in DataStore. So in order to modify it, we will have to convert it to builder and set the file that we're interested in and then build. If we want to migrate from SharedPreferences to Proto DataStore, then things are slightly more complicated because we no longer have that key value pair that makes it easy for DataStore to understand. We need to do a little bit more work. So we will have to implement our own SharedPreferences migration. When implementing this, we would get a SharedPreferences view and the current data that's in the user preferences. And we'll have to define here the mapping between these two. So, for example, we get the show completed flag from SharedPreferences, and then we set it to user preferences. But there's something a little bit more complicated here, a little bit more nuanced. So let's say that the show completed flag is true in SharedPreferences, and by default, the data store value for Boolean is false. So the first time the migration is run, the value from SharedPreferences is copied to DataStore. But then every time we're opening the application, the migration will be run. So this means that if meanwhile our users have changed that value from DataStore from true to false, the next time we're opening the application, DataStore will go through the same logic that we've implemented. So we'll see, okay, we'll get the value from SharedPreferences and override the existing value in DataStore. So what we need is an extra flag that tells us that we've already done the SharedPreferences migration. So for example, you can add this to your user preferences in the Proto, and then in the SharedPreferences migration, you can check whether the migration was done. If it wasn't, then you move copy your data from SharedPreferences to the user preferences, and if the migration was already done, then you just return the current data. Then you have to add this migration to the list of migrations when you create the data store. So a lot of times when you think about our application, we might have values like this that are saved in preferences. So something like show completed, sort order, whether notifications are enabled, and so on. So if we're working with Proto DataStore, then we have two options. We can either put all of these into one object, or do like we usually do in programming, separate responsibilities, and create two different data stores. So one related to preferences that are for our to-do list, and maybe some that are some application-wide preferences. So instead of having only one Proto data store, we end up having two data stores. So for each of them, we will have to create different Proto files and then different serializers. But this also means that whenever something changes in the to-do list related preferences, you'll only be notified on that flow that exposes the flow of to-do list preferences, not of both. Then when we talk about dependencies, similarly, Proto DataStore has two different types of dependencies, DataStore core or DataStore. So DataStore is the one that offers the SharedPreferences migration functionality. If you don't need that, then just use DataStore core in your application. So Preferences and Proto DataStore. The Preferences DataStore allows you to save small primitive data in key value pairs, and Proto DataStore allows you to save small type data backed by protocol buffers. So they offer a lot of advantages, a lot of versus SharedPreferences, but neither of them offer support for synchronous API. So this was kind of done on purpose because in the end, when you're working with data from file, well, that takes a while. And you want to avoid doing long-running work on the main thread. But if you really, really need to do synchronous work to synchronously access data from DataStore, then you can just call datastore.data and first allows you to get the first element of the flow. And then you can run this in a blocking fashion using run blocking. Then DataStore allows you, has an async API, both for read and for write data. And then it's safe to call on the UI thread because under the hood, DataStore ensures that all the work that's needed to be done is moved on a different dispatcher. And DataStore can also signal errors. Whenever you get parsing errors when reading or writing data, it will throw an IO exception or exception of whatever happened. Then DataStore gives you a transactional API with strong consistency guarantees. Using methods like update data, it allows you to have atomic read, write, update, read, update, write operation. Then DataStore also handles data migration. When it comes to Preferences DataStore, we saw that that's as simple as instantiating one class. And with Proto, you have to do a little bit more work. But then both of them offer something that SharedPreferences didn't before, which is being able to migrate from one version of your data to another. And then finally, with Proto DataStore, you get type safety. You no longer have to do that get int, put int, but you know exactly the type that you're getting, the type that you're working with. So DataStore is still in alpha, and it has a few unsupported features for now that we actually have in mind, and we actually even started working on. So, for example, if you need Java support, because right now DataStore only has coroutine support, then follow the issue tracker, the issue that is linked here. So we're working on Rx Java support instead of Flow for these APIs, and I think it's going to go out this year, so stay tuned. Then another feature that is quite often asked is encryption support and also the multi-process support, and both of these are also on our radar for DataStore. And then finally, DataStore is unbundled. So this means that you no longer have to wait for a new version of Android Studio, for a new version of the Android OS to use this API like you will with SharedPreferences. So all you have to do is add it to your app now. To find out more about DataStore, check out our documentation and our code labs for both Preferences and Proto DataStore. And that is all from me. And I think we might have some questions.